So for uniformly accelerated motion along a straight line, so this is not correct. Yeah. For uniformly accelerated motion along a straight line, let's say an object is at origin at t is equal to 0, and it is at a point A, which is at a distance x1 at t is equal to t1, and it is at a position x2 at t is equal to t2. So these are the positions which are mentioned at different times, t1 and t2, right? Now if you write the equations of this, first relation is velocity time relation. So we know that we had studied in earlier classes in ninth class that v is equal to u plus at. So we will be using this relation only, but there will be slight variation in that. So the final velocity v2, if we write v2 is equal to v1 a t2 minus t1, this t2 minus t1 is basically your time interval. So if we take t2 minus t1, so at t1 is equal to 0, let's say initial velocity is u, and final velocity is v, and time t2 is equal to t. So this t2 minus t1 is replaced as t, and v1 is replaced as u. This is the time, this is the velocity at time is equal to 0, and this is the final velocity. So the equation v is equal to u plus at comes. Now acceleration of the object, where do we derive it from? So acceleration is change in velocity by time taken. So a is equal to v2 minus v1 by t2 minus t1, and this is being derived from this. So this is your first equation of motion. Then we have the second equation is s is equal to ut plus half at square. This is our second equation of motion. And the relation which we use, the variation which we use. So we write, this is the net displacement. So final position vector x is equal to initial position vector plus ut plus half at square. So if we have to find the position vector, the position of a particle, so final position is initial position plus of this displacement. And if we only have to find displacement, we can directly use this formula. So it depends that what has been asked in the question. If final displacement, final position has been asked, we'll use this formula. If we have to find net displacement, we'll be using this formula. Now third relation is position velocity relation. So the relation is v square is equal to u square plus 2as, right? Just take a screenshot. So the position is v square is equal to u square plus 2as, right? So this is our velocity and acceleration and displacement relation. So using these, let's solve few questions. You can try this question first. Try answering this. It is simple application of equation of motion. So the question is, particle starts with an initial velocity of 2.5 meter per second. So u is given as 2.5 meter per second along the positive x direction, and it accelerates uniformly at the rate acceleration a is equal to 0.5 meter per second square. Time taken to reach the velocity of 7.5 seconds. Yes, Satpreet, correct answer. It is option 3. So along the positive x direction, and it accelerates uniformly at the rate Acceleration is given. The time to reach the velocity t we have to find. Final velocity is 7.5 meter per second. So this is simple first equation. V is equal to u plus at. We'll use the first equation. So 7.5 is equal to 2.5 plus 0.5 into t. So 7.5 minus of 2.5 divided by 0.5 is time t. So this is 5 divided by 0.5 or 10 seconds. So option 3, 10 seconds is the answer of this. Is it clear to everyone? You can try doing the next question now. Please try doing this. Yes, Betsy, it's correct answer first. Option 1 is the correct answer. So particle is situated at x is equal to plus 3 units. So that means initial position is equal to plus of 3 units at t is equal to 0. It starts moving from rest with a constant acceleration. So acceleration a is equal to 4 meter per second square. The position of the particle at t is equal to 3 seconds. T is equal to 3 seconds. We have to find the position, final position. Final position is x is equal to x naught. Starts from rest means u is equal to 0. So x naught plus ut plus half at square. This is the formula. है ना, यही फॉर्मूला सेकंड इक्वेशन ऑफ मोशन का हमने अभी देखा था. पोजीशन निकालने के लिए यही फॉर्मूला यूज करते हैं. तो फाइनल पोजीशन x is equal to 3 plus ut means 0 into 3 plus half into acceleration 4 into 3 square. So this is x is equal to 3 3s are 9 2s are 18 plus 3. So 3 plus 18 which is equal to plus of 21 units. So this is the final position. So option 1 is the correct answer. Please write this down. Done, बच्चों? Try doing this question. I'll let you know the formula. Distance traveled in nth second. So distance traveled in nth second, we had done it earlier, is given as dn is equal to u plus a by 2 2n minus 1. So this is u plus a by 2 into 2n minus 1, where n is the nth second. So you can use this formula to solve this. So what is given is a body moving with uniform acceleration describes 4 meter in third second and 12 meter in fifth second. The distance described in next 3 seconds. मतलब 5th सेकंड से स्टार्ट होके 8th सेकंड तक का डिस्टेंस निकालना। See, what is given is distance traveled in 3rd second means d3 is equal to 4 meter, or u plus acceleration a by 2, 2 into 3 minus 1, option 200. No, Betsy, option 2 is not the right answer. So this becomes distance traveled in next 3 seconds means 5th second to 8th second you have to find, Betsy. I think you have found the distance traveled in whole 8 seconds. You have to subtract from it the distance traveled in first 5 seconds. Option A is also not the right answer. चलो कोई नहीं, देखो यहाँ पे कहीं पे आप लोग कुछ कैलकुलेशन मिस्टेक कर रहे होगे, आई एम श्योर। ये 3rd सेकेंड में हम लोग निकाल रहे हैं डिस्टेंस ट्रेवल्ड, दैट इज इक्वल टू 4 मीटर। तो हमारा पहला जो इक्वेशन हो गया 6 माइनस 1 5 हो गया, तो u प्लस 5a अपॉन 2 इज इक्वल टू 4, ये पहला इक्वेशन हो गया। डिस्टेंस ट्रेवल्ड इन 5th सेकेंड d5 इज इक्वल टू 12 meter. So that means u plus a by 2, 2 into 5 minus 1 is equal to 12. So this will be u plus 10 minus 1, 9a by 2. So u plus 9a by 2 is equal to 12, second equation. अब इन दोनों इक्वेशन को सॉल्व कर दो आप। तो सॉल्व करने के लिए आप सेकेंड इक्वेशन से फर्स्ट इक्वेशन को सब्ट्रैक्ट कर लो। सब्ट्रैक्टिंग 1 from 2 we'll get so this is u plus 9a by 2 is equal to 12. इससे सब्ट्रैक्ट कर लें u plus 5a by 2 is equal to 4. इनको सब्ट्रैक्ट कर देंगे, u कैंसिल हो जाएगा, 9 minus 5 is 4a by 2 is equal to 8, और a is equal to 4 meter per second square. एक्सेलरेशन 4 मीटर पर सेकेंड स्क्वायर आ गया। अब किसी में भी यूज कर लो, इसमें यूज कर लो, फर्स्ट वाले में तो u प्लस 5 इंटू 4 बाई 2 इज इक्वल टू 4। इसको सॉल्व किया तो u इज इक्वल टू 4 माइनस 10 विच इज माइनस 6 मीटर पर सेकेंड। सो इनिशियल वेलोसिटी इज माइनस 6 मीटर पर सेकेंड, एक्सेलरेशन इज 4 मीटर पर सेकेंड स्क्वायर, राइट। तो ये दोनों चीज निकल गया अब हमारा। अब ठीक है, अब हमें निकालना है डिस्टेंस ट्रेवल इन नेक्स्ट 3 सेकेंड मीन्स between 8 second and between 8 second and 5 second. So distance travel in 8 second minus distance travel in 5 second. This is what we have to find. So this will be equal to distance travel in 8 second is ut plus half at square. मतलब u into 8 plus half into acceleration a into 8 square minus u into 5 plus half a into 5 square. So values put कर लो u और a का. u का value है -6, a का value है 4. So this will be equal to 8 into -6 -48 plus half into 4 into 64 minus u into 5. So this is -30 plus of half into acceleration is 4 into 5 square. So minus 48 plus 128 minus of -30, 25 into 2 is plus 50. So you will get 128 minus of 48. So this is 60 minus of -30. 60 plus 30 minus of 50. Right. We have done something wrong. Okay, this is 80, sorry. So this is 110 minus of 50. So this will be equal to 60 meter. So the answer here is 60 meter, option 3. Clear है बच्चों? Is it clear to everyone? Okay, so let's do the next one. Now this is a question where we are taking care of overtaking of one vehicle by the other vehicle. So I'll do this for you so that you can learn how to do these kind of questions. A burglar's car. So a burglar's car had a start with an acceleration of 2 meter per second square. So it started with an acceleration of 2 meter per second square. A police vigilant party came at a point of start after 5 seconds and continued to chase the burglar's car with a uniform velocity of 20 meter per second. So a police vehicle came at that point 5 seconds after the start. So after this burglar has started, after 5 seconds, the police party came and they moved with a uniform speed of 20 meter per second. Find the time in which the police van overtakes the burglar car. So we have to find the time in which the police van. So let's say so this is the police van and this is the burglar's car. Okay. So police van is moving at a speed of 20 meter per second. The burglar is moving with an acceleration a is equal to 2 meter per second square, and the time for which it has accelerated, initial velocity is 0 meter per second. So distance between these two, right? Because when the police van reached the spot, this burglar had already moved for 5 seconds. So distance traveled by the burglar is the initial distance between these two. So relative distance सो जो पहले डिस्टेंस था इन दोनों के बीच में उसको रिलेटिव डिस्टेंस कहते हैं. तो रिलेटिव डिस्टेंस बिटवीन द कार एंड पुलिस वैन इज इक्वल टू इनिशियल रिलेटिव डिस्टेंस कर लो. जब पुलिस वहां पे पहुंची तब जो रिलेटिव डिस्टेंस था that is equal to half at square. U is 0, ut plus half at square. So you will put the values 0 into 5 plus half. Acceleration is 2 into 5 square. So this will become 25 meter. This is the distance, initial distance. Now they start moving in the same direction. Let's say the police van catches the burglar after tea time. After t dash time, it catches the burglar. So the distance moved now by the burglar and distance moved by the policeman, this distance is 25 meter initial. So distance moved by the burglar car plus 25 meter will be the distance moved by the पुलिस वैन. सो दोनों सेम डिस्टेंस मूव करेगा. अगर यहाँ पे इसको कैच करना है और यहाँ पे इस पॉइंट पे ओवरटेक करना है, लेट्स से टी डैश टाइम के बाद, सो लेट द पुलिसमैन ओवरटेक्स द बर्गलर्स कार आफ्टर टाइम टी टाइम के बाद इसको ओवरटेक कर लेता है, लेट्स. ठीक है. सो उस केस में क्या होगा कि बिकॉज इट इज ओवरटेकिंग द कार आफ्टर टी डैश टाइम, टी डैश, ठीक है, तो उसमें क्या होगा कि जो डिस्टेंस मूव्ड बाय पुलिस वैन ड्यूरिंग दिस टाइम, डिस्टेंस मूव्ड बाय पुलिस वैन in t dash time is equal to distance moved by burglar in t dash time plus of relative distance between them plus of initial relative distance between them. So this is the whole concept basically. So पुलिस वैन जो टी टाइम में कितना डिस्टेंस ट्रैवल किया, दिस इज स्पीड इनटू टाइम because it is moving with a uniform velocity, and distance moved by burglar is ut plus half at square. Right. So here the initial speed now, so after 5 seconds what would have been the velocity of this? v is equal to u plus at करके हम लोग वेलोसिटी निकाल लेंगे 5 सेकेंड के बाद. जब ये पुलिस वैन वहां पहुंचा तो 0 plus 2 into 5, so this is 10 meter per second. So by the time the police van reached here, it was already moving with a speed 10 meter per second. So this is the initial velocity which we will be taking ut के जगह. So this is u dash t dash plus half a. So this final velocity here is equal to initial velocity for the next motion, half a t dash square. So we'll put velocity is 20 into t dash is equal to u dash t, means initial velocity 10 into t dash plus half acceleration 2 है t dash square. So we'll cancel this. So 20 t dash and t dash here, you will bring it here, t dash square minus of 10 t dash is equal to 0. So t dash into t dash minus 10 is equal to 0. So t dash is equal to 10 seconds. So the police van overtakes the burglar in 10 seconds. Is it clear, बच्चों? So this one we missed this plus of 25 भी था ना? I'm sorry, we missed this 25 here. So t dash square minus 10 t dash minus 25 is equal to 0. So this is, we'll have t dash minus of 5 whole square is equal to 0, or t dash is equal to 5 seconds. So 5 seconds after this. Okay, we missed out this portion, initial relative distance between them, which was 25 initially. Now it's correct. Is it clear? So now let's move to the graph portion. So we had already done position time graph and velocity time graph for an object which was moving with uniform velocity. Now we'll be doing these graphs when object is moving with accelerated motion. So when an object is moving with zero acceleration, then in that case the velocity is constant. So VT graph for a uniformly moving object, yeah, uniform motion will be a line which is parallel to time axis, because every point you will see that as time proceeds velocity remains constant, है ना? Velocity मान लो ये v naught था, तो ये v naught will be constant as time proceeds. So we call this motion, so this is a graph for uniform velocity for an object moving with uniform velocity. Okay. Second one, when an object is moving with constant positive acceleration, the VT graph will be a straight line. So if an object is moving with uniform positive acceleration, so this is the graph for object moving with uniform positive acceleration, right? So you will find that in this case, the slope gives the acceleration, and this angle theta should be acute, so that this is a positive acceleration. If it is obtuse, then it will be a negative acceleration, as we'll see in the next slide. Now, this is a graph for an object moving with positive constant acceleration. ठीक है ना? तो ये positive constant acceleration having some initial velocity. पुराने वाले इसमें देखेंगे तो initial velocity यहाँ पे 0 है. For this motion, the initial velocity is 0, having 0 initial velocity. That's why at time t is equal to 0, the velocity is 0. Now, in the other case here, if you see, here the initial velocity is not 0. At time t is equal to 0, the velocity is, some value. Let's say it is u. So in this case, you will get a straight line which is cutting this velocity axis at v is equal to u. तो ये u पे आके इसको कट करेगा, जो कि इनिशियल वेलोसिटी को शो कर रहा है. सो बेसिकली this is a graph for uniform velocity, so uniform acceleration, sorry, So this is a graph of motion of an object with uniform acceleration and some initial velocity. So uniform acceleration and some initial velocity. Okay. Now, when an object is moving with increasing acceleration, so this is a graph of object moving with non-uniform acceleration. Increasing acceleration का मतलब acceleration constant नहीं है. So this is a graph of object moving with increasing acceleration. So in that case vt graph will be bent upward, है ना. ये ग्राफ जो है ऊपर की तरफ concave होगा, right? So bending upward. So this is non-uniform acceleration with acceleration increasing, okay, with increasing acceleration. If you see, negative acceleration, object moving with negative acceleration, constant negative acceleration, you will get a graph like this. So here you can see the slope is negative. Why? Because this angle theta is greater than 90 degree, obtuse angle है. तो slope यहाँ पे negative है. Slope negative है तो acceleration भी negative होगा. So this is uniform negative acceleration. This is an object moving with the graph of an object moving with uniform negative acceleration. Now, and where initial velocity is some value, final velocity is 0. Now, when an object is moving with uniform negative acceleration having some negative initial velocity, this is when it is having a positive initial velocity, and this is when it is having a negative initial velocity. It starts only with a negative velocity. So this is a graph of an object moving with uniform negative acceleration, right? Moving with uniform negative acceleration and having negative initial velocity. Now, this is the graph of an object when an object is moving with uniform negative acceleration, having positive initial velocity, changes direction of motion at time t is equal to t1, but continuously moving with uniform acceleration. Okay. The velocity time graph is a straight line. So in this case, if it is moving with uniform negative acceleration, initial velocity positive था, but velocity का direction कब change कर रहा है? At time t is equal to t1, it changes its direction. Okay. So जहाँ पे direction change करेगा वहाँ velocity negative हो गया. So जहाँ पे ये x axis मतलब time axis को ये velocity time graph cut करता है, उस पॉइंट पे उस टाइम पे इसका बेसिकली डायरेक्शन चेंज हो जाता है वेलोसिटी का. सो इनिशियली यहाँ से यहाँ तक पॉजिटिव वेलोसिटी था और इसके बाद नेगेटिव वेलोसिटी. मतलब एक ऑब्जेक्ट इधर राइट की तरफ जा रहा है धीरे धीरे डिसेलरेट करके. इनिशियल वेलोसिटी कुछ यू रहा होगा, फाइनल वेलोसिटी 0 जब हो गया उसके बाद ये टर्न कर जाएगा, टर्न करके उल्टी दिशा में उल्टे डायरेक्शन में ये मूव करना शुरू कर देगा, राइट. सो and when does it happen? At t is equal to t1. इस टाइम पे ये ऐसा होगा. Clear है बच्चों? So this is the graph of this kind of motion. Uniform negative acceleration having some positive initial velocity, and the object changes its direction at time t is equal to t1. Now, positive position time graph for accelerated motion. So if you find the position time graph, अभी तक हम लोग velocity time graph देख रहे थे, अब position time graph देखेंगे different motion का. तो जब accelerated motion होता है position time graph का तो एक parabolic curve बनता है. The graph is a parabola with curve with the mouth of the parabola opening upwards. So mouth upward. Parabola का shape जो होता है, this is the shape of the parabola. So basically mouth opening upward is the positive acceleration. So when in position time graph, so this is a position time graph, xt graph भी कहते हैं इसको. Position time graph को we call it xt graph also. So position time graph of a object moving with uniform positive acceleration. Now, if we have to find position time graph of an object moving with negative acceleration, it will be a parabola mouth opening downward. So, देखो mouth opening downward हो रहा है. So, this is a position time graph of an object moving with uniform deceleration or uniform retardation. So, object moving with uniform retardation. Now, it is to be noted that the slope of the position time graph at any instant of time gives the instantaneous velocity of the object at the given time. So, you can see here, ये slope ज़्यादा है, ये slope कम है, ये slope 0 हो गया और फिर slope negative हो गया. तो slope धीरे धीरे कम होता जा रहा है. पहले ज़्यादा था, फिर उससे कम हुआ, फिर 0 हुआ और फिर negative हो गया. तो because slope is reduced, getting reduced, that means this graph is of negative acceleration. Because the velocity slope is getting reduced, that means the velocity is also getting reduced, and when the velocity gets reduced, then we get an acceleration, negative acceleration. Now, third point, when an object is moving with zero acceleration. So when we talk about zero acceleration, so when the object is moving with zero acceleration, the position time graph is a straight line EF. So this is the position time graph. So in this case, you will see that the object is moving with uniform velocity. So because zero acceleration means uniform velocity. So when an object is moving with zero acceleration, that means it is moving with uniform velocity. And in that case, position time graph will be a straight line. It will not be a curve. Now, velocity time graph of a uniformly accelerated motion. So if you see a velocity time graph of a uniformly accelerated motion, there are two things which we can find here. So if we have to find the velocity here, the acceleration here, the slope of VT graph is gives the acceleration. So acceleration can be found out by the slope of velocity time graph. So slope of VT graph gives acceleration. And distance can be found out by area under the VT graph. Area under velocity time graph gives us distance. So acceleration is given by slope of VT graph and distance is found out by area under VT graph. So acceleration of an object in a uniformly accelerated motion in one dimensional is equal to the slope of velocity time graph with time axis. And distance traveled is found by the area of the trapezium, means area under the velocity time graph. So distance traveled by an object in a given time interval of uniformly accelerated motion is equal to area under velocity time graph with time axis. Okay. So distance traveled is area under velocity time graph. Now, if you have some velocity time graph like this, so let's say from time t is equal to t1 and then t2. So we know that if we have to find distance traveled, we'll have to, so this is basically velocity time graph. So this is origin, इसके नीचे velocity negative है और ये time t है. तो जो the area which is above the time axis, this will be positive area, and the area which is below the time axis, this will be negative area. So if we have to find, so let's say the area here is A1 and the area here is A2. So if we have to find distance, then positive and negative does not matter. We just take the magnitude of it. मतलब उसका एब्सोल्यूट वैल्यू ले लेते हैं. मतलब एरिया एरिया निकाल के दोनों एरिया को ऐड कर देंगे तो हम लोग डिस्टेंस निकल जाएगा. और यही अगर हम लोग को डिस्प्लेसमेंट निकालना होगा तो डिस्प्लेसमेंट के केस में हम लोग को साइन भी कंसीडर करना पड़ेगा कि ये वाला जो एरिया है ये नेगेटिव एरिया है, तो a1 माइनस a2 करते हैं यहाँ. सो टू फाइंड द डिस्प्लेसमेंट वी फाइंड द डिफरेंस ऑफ बोथ द एरियाज ओनली इफ इट इज डिफरेंस इसलिए निकाल रहे हैं बिकॉज इट इज बिलो द टाइम एक्सेस, नेगेटिव वेलोसिटी है यहाँ. So for displacement we find the difference of the areas, and for distance we add the areas. Is it clear? This is for that particle which changes its direction during the time interval. Clear है बच्चों? So यही सेम चीज यहाँ लिखा भी है. देखो तो total distance of the body in the given time is equal to area which velocity time graph encloses with time axis, and the area to be added with proper signs. So if we have to find displacement, we'll have to take negative sign also. But distance अगर निकालना होगा तो then we'll just add up two areas, both the areas. Now in this question, you need to tell me answers of these graph related questions. So 134th. The question is distance time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at what point? किस point पे negative velocity होगा? वेलोसिटी निकालते कैसे हैं? इंस्टेंटेनियस वेलोसिटी डिस्प्लेसमेंट टाइम ग्राफ से स्लोप निकाल के निकालते हैं. स्लोप नेगेटिव कहाँ पे होगा? स्लोप नेगेटिव कब होगा? जब जो एलिवेशन है, जो एंगल बन रहा है एक्स एक्सिस, पॉजिटिव एक्स एक्सिस से, वो ऑब्ट्यूस होगा तो स्लोप नेगेटिव होगा. तो सी पॉइंट पे अगर तुम देखोगे यहाँ पे स्लोप पॉजिटिव है, यहाँ भी स्लोप पॉजिटिव है, राइट? ये भी स्लोप पॉजिटिव, ये भी स्लोप पॉजिटिव. यहाँ पे अगर देखोगे यहाँ पे स्लोप क्या हो जा रहा है? ये देखो एंगल क्या बना रहा है? ऑब्ट्यूस. तो ये क्या हो जाएगा? स्लोप नेगेटिव हो जाएगा. यस शिफा, करेक्ट आंसर, फोर्थ ऑप्शन ई. यहाँ पे स्लोप पॉजिटिव हो गया. तो ये स्लोप पॉजिटिव, ये स्लोप पॉजिटिव. स्लोप पॉजिटिव का मतलब जब हम लोग राइट के तरफ मुड़े, राइट के तरफ मूव करेंगे तो वो उसका जो डिस्प्लेसमेंट है वो बढ़ना चाहिए टाइम इंक्रीज करने से, है ना? तो यहाँ पे टाइम बढ़ा रहे हो, डिस्प्लेसमेंट बढ़ रहा है. स्लोप ऐसे पॉजिटिव है, एक्यूट एंगल, एक्यूट एंगल, यहाँ भी एक्यूट एंगल. ये जो है ऑब्ट्यूस एंगल नीचे के तरफ आ रहा है. ये सब ऊपर के तरफ जा रहा है राइट जाने पे, यहाँ राइट जाने पे नीचे के तरफ आ रहा है, इसीलिए इसमें स्लोप नेगेटिव होगा और वेलोसिटी, इंस्टेंटेनियस वेलोसिटी नेगेटिव होगा. बहुत सारे तरीके हैं देखने के. इन सब एंगल्स को निकाल के भी कर सकते हैं कि जो एंगल आएगा वो एंगल का हम लोग फिर चेक करते हैं कि क्या कितना एंगल एक्स एक्सिस से बन रहा है. Now let's go to the next one. Try doing this. देखो पोजीशन टाइम ग्राफ दिया हुआ है, हम लोग को इसका वेलोसिटी टाइम ग्राफ बनाना है. सबसे पहले तो ये देखो कि पोजीशन टाइम ग्राफ, ये पैराबोला का माउथ ओपनिंग डाउनवर्ड होता कब है? So when is the position time graph with parabola mouth opening downward? When is this graph made? देखो हम लोगों ने पोजीशन टाइम ग्राफ 3 किया था, एक यूनिफॉर्म वेलोसिटी में स्ट्रेट लाइन, एक यूनिफॉर्म एक्सेलरेशन में ऐसा, और यूनिफॉर्म डिसेलरेशन में ऐसा। अब देखो ये क्या है, ये पैराबोला माउथ ओपनिंग डाउनवर्ड, ये जो पैराबोला माउथ ओपनिंग डाउनवर्ड, नहीं शिफा सेकंड आंसर नहीं है, एक बार और फिर से देखो। तो पैराबोला माउथ ओपनिंग डाउनवर्ड है, मतलब डिसेलरेटेड मोशन, ठीक है। सो ये डिसेलरेशन हो रहा है यहाँ पे, राइट, रिटार्डेशन जिसको बोले। रिटार्डेशन बनाएंगे तो जो ग्राफ रिटार्डेशन का होता है, दैट इज यू नो something like this, going downward. So which is the graph is which is like that? This is the first option. So this is the velocity time graph. Velocity time के साथ डिक्रीज करेगा ना, it will be a straight line, और यूनिफॉर्म डिसेलरेशन हो रहा है, ठीक है। तो यूनिफॉर्म डिसेलरेशन हो रहा है, इसीलिए इस तरह का ग्राफ। यहाँ पे तो एक्सेलरेट करेगा, इसमें यहाँ पे पहले डिसेलरेट करेगा, पहले एक्सेलरेट करेगा, बाद में डिसेलरेट करेगा। एक्सेलरेट तो कर ही नहीं रहा, और यहाँ पे पूरे टाइम में एक्सेलरेट करेगा। सो दिस इज नॉट देयर, दिस इज नॉट देयर, दिस इज आल्सो नॉट देयर, ओनली ऑप्शन इज दिस। इज इट क्लियर बच्चों? ट्राई सॉल्विंग दिस। No, Betsy, fourth option is not answer, not the correct answer. See, the question is, a train moves along one station from one station to another in 2 hours time. Its velocity time graph is during this motion is shown the maximum acceleration. ये देखो VT ग्राफ दिया हुआ है ये पूरा, सो इधर वेलोसिटी हुआ y एक्सिस पे और इधर टाइम है, VT ग्राफ है। मैक्सिमम एक्सेलरेशन कब होगा? व्हेन द स्लोप इज मैक्सिमम। ये एक स्लोप हो गया, यहाँ स्लोप 0 हो गया, ये स्लोप पॉजिटिव है और ये स्लोप नेगेटिव है, तो यहाँ तो डिसेलरेशन हो रहा है, ये हट गया। यहाँ इन दोनों में स्लोप ज्यादा किसका है, ए बी या सी डी का? सी डी का स्लोप ज्यादा है, तो दिस इज द पोर्शन व्हेन यू गेट अ मैक्सिमम एक्सेलरेशन, ठीक है। अब ये मैक्सिमम एक्सेलरेशन आपको मिल रहा है, अब आप क्या करेंगे, मैक्सिमम एक्सेलरेशन निकालना है आपको। एक्सेलरेशन कैसे निकालते हैं? स्लोप ऑफ वीटी ग्राफ। सो maximum acceleration is at CD and which is equal to slope of VT graph. Slope of VT graph यहाँ पे ये देखो, ये जो डिस्टेंस होगा DL by LM करेंगे, DL by LM। DL मीन्स ये 60 है और L क्या है, 20 है। दिस इज एट 20, दिस इज एट 60, सो दिस डिस्टेंस is basically 60 minus 20 divided by ml, ये distance, this is 1, see 0.25, 0.75, 1, ये हो जाएगा 1.25, तो 1.25 minus 1, lm क्या हो जाएगा 1.25 minus 1, 60 minus 20 is 40 and 1.25 minus 1 is 0.25, so this is equal to 160 meter per second square. maximum kilometer per hour square. The unit is kilometer in hours, so kilometer per hour square. Is it clear, everyone? Betsy, is it clear? Now let's go to the next one. Please attempt this. So the relation between the displacement and time is given, the position and time. X is equal to 6 minus 40 plus 60 square. You have to find the velocity of the particle. You have to find the VT graph. So for that, you should know the velocity and time dependence. So for that, what you need to do is differentiate this position time relation. You will get a velocity time relation, and then you will check which of the graphs satisfies that relation. Nay, Betsy, it is not second option. You will have to check at time t is equal to 0 what is the velocity, whether it is positive, 0 or negative. See, इन तीनों में ना VT ग्राफ तुमको यूनिफॉर्म एक्सेलरेशन वाला ही है, बट तुमको चेक ये करना पड़ेगा कि इनिशियल वेलोसिटी क्या है. ठीक है, इनिशियल वेलोसिटी यहाँ पॉजिटिव है, यहाँ 0 है, यहाँ पे नेगेटिव है. तो चेक द इनिशियल वेलोसिटी बाय पुटिंग t इज इक्वल टू 0. सो हमारे पास जो पोजीशन दे रखा है x इज इक्वल टू 6 माइनस 40. यस शिफा, राइट आंसर बेटा. 6 minus 40 plus 60 square. So if you have this position, you will differentiate it to get the velocity. So velocity is dx upon dt. 6 को differentiate करेंगे 0 हो जाएगा, minus 4 into 1 plus 12t हो गया, है ना. So that means the velocity v is equal to 12t minus 4. This is the relation of velocity and time. So this is a linear relation. आप देख रहे हैं ये linear equation है velocity और time के बीच में. तो linear relation जब भी होता है तो straight line बनता है graph, right? We know that for a linear equation in one variable, two variable, you will always get a straight line graph. So straight line graph बनेगा, ये तो पक्का है, ये वाला गलत हो गया. अब हम लोगों को इसमें चेक करना है t is equal to 0 पे. So at t is equal to 0, if you check, v is equal to 12 into 0 minus of 4. So v is equal to minus 4 meter per second. That means initial velocity negative है. तो ये भी हट गया, जहां initial velocity 0 था. t is equal to 0 पे यहाँ velocity positive है, ये भी गलत हो गया. Only thing correct is this one. Clear है बच्चों? Now let's move to the next one. So you have to find the displacement and distance. यहाँ पे वही एरिया वाला कॉन्सेप्ट लगाएंगे. वेलोसिटी टाइम्स ग्राफ से डिस्टेंस निकालना होता है या डिस्प्लेसमेंट निकालना होता है. वी फाइंड द एरिया अंडर द वेलोसिटी टाइम ग्राफ, राइट. सो एरिया निकालेंगे. डिस्प्लेसमेंट में हम लोग को नेगेटिव एरिया को सब्ट्रैक्ट करना पड़ेगा जो टाइम एक्सिस के नीचे है ना. और डिस्टेंस में तीनों एरिया को ऐड कर देंगे. ये टाइम हो गया, इधर वेलोसिटी हो गया. Displacement is given, distance or displacement is given by these areas which you will find. So you will find all these areas. Okay, इसका area let's say A1 है, इसका A2 है और इसका एरिया A3 है। अगर डिस्प्लेसमेंट निकालना होगा तो A1 से A2 को सब्ट्रैक्ट कर देंगे, A1 A3 ऐड करेंगे और A2 सब्ट्रैक्ट करेंगे, और डिस्टेंस निकालना होगा तो तीनों को ऐड करेंगे। निकाल के बताइए क्या आ रहा है आंसर फटाफट। Yes, Sifa, correct answer. First one is the correct answer. Very good. Great. You are picking up fast. बहुत बढ़िया। तो अभी हम लोग क्या करेंगे, पहले A1 निकाल लेते हैं। इसका एरिया क्या होगा, ये देखो टाइम एक्सिस में 2 हो गया और इधर 4 हो गया, तो ये रेक्टेंगल है, 4 इंटू 2 8 हो गया। यहाँ पे टाइम एक्सिस ये 2 हो गया और ये जो हाइट है ये भी 2 है, 2 इंटू 2 4 हो गया। और ये जो एरिया निकालेंगे, this is 2 into again 2, 2 into 2, this is again 4. So if we have to find displacement is A1 minus A2 plus A3. This is 8 minus 4 plus 4, which is equal to 8 meter. And we have to find distance. This is equal to A1 plus A2 plus A3. So distance निकालना है, 8 plus 4 plus 4. So this is 16 meters. Clear बच्चों? Let's move to the next one now. See, in this question, a particle moves along a straight line for 4 seconds. So total time 4 second तक movement हो रहा है, and velocity time relation is v is equal to t minus 2, right? तो ये vt relation जो है, this is a linear relation, so you will get a straight line, right? Where t is in time, t is the time in second. Find the distance and displacement of the particle. So you have to find the distance and displacement for 4 seconds. So अब आप क्या करो, डिस्टेंस डिस्प्लेसमेंट निकालना है, ग्राफ बनाना पड़ेगा। तो आप अलग अलग इस पे देख लो, एट t इज इक्वल टू 0 v इज इक्वल टू -2 हो जाएगा, t इज इक्वल टू 1 v इज इक्वल टू -1, t इज इक्वल टू 2 you will get v is equal to 0, t is equal to 3 पे v is equal to 1, t is equal to 4 पे v is equal to 2 and so on. राइट, हमें 4 सेकेंड तक का निकालना है। तो अब इसका ग्राफ अगर हम लोग बनाएंगे, ये 1 हो गया, ये 2 हो गया, राइट, दिस इज -1, दिस इज -2, सो दिस इज वेलोसिटी एंड दिस इज टाइम। टाइम में 1 2 3 and 4. So at t is equal to 0 it is -2, t is equal to 1 it is -1, as in this point. At t is equal to 2 it is 0, 3 पे 1 है और 4 पे 2. So this is, if you draw this line, So this is the graph, basically VT graph. Now we have to find the distance and displacement. So what you will do, you will find this area. You will find this area A1 as well as A2. So A1 and A2 both will be equal. A1 is equal to A2 is equal to half into base into height. So this is 2 meters. एरिया 2 यूनिट्स हो गया, तो डिस्प्लेसमेंट निकालना है. डिस्प्लेसमेंट हो जाएगा A1 minus A2. A1 minus A2, that means 2 minus 2 is 0. And distance निकालना है. Distance is equal to A1 plus A2, which is equal to 2 plus 2, that is 4. So the answer is first option. Distance is 4 and displacement is 0. Is it clear to everyone? Let's move to the next one. Try doing this. We have to find the average acceleration in first 20 seconds. So this is the acceleration time graph. If you have to find the velocity, you will find the area. Average acceleration means net displacement, total displacement by total time. So average acceleration is equal to net displacement Yes, Shifa. You have to ask something? Answer option is no, third option is not correct. Try to see if you have done it correctly or some mistake is there. So average acceleration is total displacement, net change in velocity by time taken. So change in velocity by time taken, that is delta V upon delta T. तो इसको हम लोग निकालते कैसे हैं? बेसिकली एरिया अंडर एटी ग्राफ area under acceleration time graph is equal to delta V. अब 20 सेकेंड तक के लिए निकालना है. या फर्स्ट वन इज करेक्ट सिफर, करेक्ट. सो 20 सेकेंड तक के लिए निकालना है एवरेज एक्सेलरेशन, मतलब सॉरी या एवरेज एक्सेलरेशन 20 सेकेंड तक का निकालना है. तो ये डेल्टा वी इससे निकल जाएगा, इसका एरिया निकालेंगे. सो एरिया अंडर 80 ग्राफ विल गिव यू डेल्टा वी for t is equal to 20 सेकेंड. तो एरिया कितना हो जाएगा? डेल्टा v इज इक्वल टू हाफ इंटू सम, ये ट्रेपीजियम का एरिया हाफ इंटू सम ऑफ पैरेलल साइड्स है. तो पैरेलल साइड, ये जो साइड है इसका लेंथ 10 है, 10 यूनिट्स, और इसका जो लेंथ है ये 20 यूनिट्स. सो हाफ इंटू सम ऑफ पैरेलल साइड्स 10 प्लस 20 इंटू हाइट, हाइट इज अगेन 20 यूनिट्स. So this will be 10. 20 plus 10 is 30 into 10 is 300 meter per second. So delta V is 300 meter per second. Average acceleration will be delta V upon delta T. So delta V is 300, change in velocity, right? So change in velocity is 300 and change in time, the time interval is 20. So you will get 15 meter per second square. So this is first one. Is it clear? Try doing this. See, in this question, we have a particle is moving along a straight line as shown in the figure below. Now, what is the, ये देखो VT graph, velocity or displacement graph दे रखा है. What is the magnitude of acceleration when displacement is 3 meters? So, when you see this, at s is equal to 3 meters, the velocity is 4 meters per second. Right? Now, at s is equal to, yes, correct answer, Shifa. First one is the correct answer. So at s is equal to, yeah, at s is equal to 3 meter, v is equal to 4 meter per second, and the angle here, right, theta is equal to 120 degree. So acceleration is given by velocity into 1030 degree. तो मैग्नीट्यूड पूछा है हम लोग को. dv by ds is equal to tan theta. So we can write dv is equal to ds tan theta. अब दोनों तरफ क्या करो आप, देखो इसका स्लोप जो है dv by ds कहलाएगा, इसका स्लोप, क्योंकि वेलोसिटी डिस्प्लेसमेंट ग्राफ है. dv by ds is equal to tan theta, dv is equal to ds tan theta. अब आप क्या करें, दोनों तरफ टाइम से डिफरेंशिएट कर दें, मतलब टाइम dt से डिवाइड कर दीजिए. So this will be dv by dt is acceleration a is equal to velocity v into tan theta. ये रिलेशन हो गया एक्सेलरेशन और वेलोसिटी. वेलोसिटी हम लोग निकाल चुके हैं 3 मीटर पे 4 मीटर पर सेकेंड है. a is equal to 4 मीटर पर सेकेंड into tan theta. थीटा 120 डिग्री है, tan 120 डिग्री हो जाएगा. एक्सेलरेशन इज 4 into tan 120 डिग्री. तो ये सेकेंड क्वाड्रेंट है, सेकेंड क्वाड्रेंट में नेगेटिव होता है, tan का वैल्यू, तो -√3 हो जाएगा, 180 - 60 इसको लिख सकते हैं, 4 into tan 180 - 60 degree. So this is what, second quadrant. So tan 60 is √3, so 4 into -√3 minus 4√3. If we have to find the magnitude of this, so magnitude will be equal to 4 absolute value of this 4√3 meter per second square. So option 1 is the answer. Is it clear? Great that you guys are picking up. There is one portion more which is remaining in this chapter, motion in a straight line. So that is, motion under gravity. So when an object is moving under gravity, so how does that behave? How does it behave? And the question based on that. So उसके questions काफी interesting होते हैं, उसको भी हम लोग करेंगे. So what we'll be doing next in the next class